Okay, we're going to be talking about the Maclaurin series, but in order to talk about the Maclaurin series, we have to define Taylor series. And in a previous video, I've already mentioned the Taylor series. The Taylor series occurs when we have a function, f, all right, with derivatives of all orders throughout some interval containing a as an interior point. The Taylor series generated by f at x equals a is just this summation from k equals 0 to infinity, and it's f to, and it's not the power k so much as it's the derivative, the kth derivative of a over k factorial times x minus a to the k. So what it evaluates to here is this f of a plus f prime of a times x minus a plus f double prime of a over 2 factorial times x minus a squared, and so forth and so on, that you have the nth order derivative of a over n factorial times x minus a to the nth, and so forth and so on. So it's a pattern that's followed. Now, the Taylor series, or which is what we talked about again in the previous video, helps us generate the Maclaurin series because it's the same thing. All right, the difference is that in Maclaurin, we're saying a is 0. So that's why it says generated by f at x equal 0. So it's a very special case. All right, so we're going to try to generate a polynomial, but in generating the polynomial, we're going to see if we can come up with the series itself. All right, the series that will generate, in this case, for us on this example, e to the minus x. All right, about x equal 0. All right, so we're going to write that in here. I'm going to write x equals 0. This is what makes it Maclaurin. All right, this is what makes it Maclaurin. So what we have to do here is we have to first find a couple of derivatives. So let's just say we'll take 3 orders of derivatives. All right, I know that f of x equals e to the minus x. Okay, so I'm going to probably need that at some point. All right, let's see. Then I'm going to take the derivative. So it's a kind of a chain rule. It is a chain rule. It's e to the minus x times the derivative of the exponent, which is just going to be a negative 1. So we're going to have basically a negative e to the minus x. And then when we take the second order derivative, we're going to get a negative e to the minus x, negative e to the minus x, multiplied by the derivative of the top, which is going to be a negative 1, which is going to give us just a positive e to the negative x. And let's go ahead and take the third order derivative here, just for good measure. And so we end up with e to the minus x, okay? And we have already taken the derivative up here at the top, okay? So the derivative is going to be this right here, the first order derivative, which was e to the minus x times a negative 1, which is negative e to the negative x. And the pattern actually continues. All right, so we've got that down. Now let's go ahead and find the values that we're going to need. So let's say f of 0. Well, when we plug in 0, that's e to the negative of 0. So this is e to the 0, which is just 1. Then we're going to take f prime of 0, which is going to be a negative e to the negative of 0. So this is a negative 1 when you think about it. Okay. Now we're going to take f double prime of 0. And this is going to be e to the negative of 0, which is just going to be 1. All right. And then f triple prime, or the third order derivative rather, is going to be a negative e to the negative of 0, which is going to be a negative 1. So you should start seeing that it's alternating here. It's kind of an alternating series, if you will. So let's go ahead and see what this polynomial function would look like. All right. So first off, we start off, as the formula says, f of a. So in this case, f of 0, which is just 1 for us, plus, and then we're going to say f prime of a times x minus a, but in this case, it's just x. All right, so it's going to be a negative 1, because that's f prime of a, negative 1 times x, plus, and then we take the second order derivative, and we divide it by 2 factorial. So we're going to say the second order derivative was 1 over 2 factorial multiplied by x minus a squared, which is just going to be x squared because a is 0. And then we're going to say minus in this case, so plus a negative 1 divided by 3 factorial multiplied by x minus a cubed. A again is 0, so it's just an x cubed, and so forth and so on. So we see here that it's clearly alternating, okay? It is clearly alternating. And we end up with a pattern that looks like this. I want you to think about this, all right? Because this is what ends up happening, all right? Think about it. All right, we start off at 0. That's going to be negative 1 to the 0. That's 1, right? Over 0 factorial, which is just 1. X to the 0 is 1. So we end up with 1, and then so forth and so on. So it's an alternating series, if you will. All right, so what does this look like? Well, this produces the Maclaurin series from n equal 0 to infinity, and it's an alternating series, negative 1 to the nth over n factorial times x to the power n. All right, really nice. And let me change my color here. Should be red. It's the answer. All right, I think we've got time for one more example. So let's go ahead and take a look at the next example. We'll call this one number 4. All right, so we have a function 1 over 1 plus x. All right, and that looks kind of funky. Erase that really quickly. 1 plus x. There we go. We're going to take a look at this about x equals 0. Again, this is what makes this a Maclaurin series. All right, so what does this look like? X plus 1 times to the negative 1. That's the original function f of x, because we're going to need to find derivatives, and we're going to find a few derivatives. Let's take the third order again. That should work for us. So we're going to say, okay, f prime of x, the first derivative, is going to be a negative 1 times x plus 1, in this case to the negative 2 multiplied by 1. F double prime of x is going to be a negative 2 times negative 1, so that's a positive 2, times x plus 1 to the negative 3 multiplied by 1 again. And then the third order derivative is going to be a 2 times a negative 3 multiplied by this x plus 1, in this case to the minus 4, multiplied by a 1. All right, so let's just see what these look like really quickly. This is a negative 1 over x plus 1 quantity squared. This is a 2 over x plus 1 quantity cubed. This is a negative 6 over x plus 1 to the 4th. Okay, looks just like that. And so what do we have? We have f of 0. And when we plug in 0, we get 1 over 1 plus 0, which is just 1. Then we're going to take f prime of 0, and that is going to give us negative 1 over 0 plus 1 squared. That's going to give us a negative 1. Now we're going to take a look at f double prime of 0, and that's going to be 2 over 0 plus 1 cubed, so that's going to be a 2, right? Multiplied by 1 over 2 factorial, which is just going to yield 1, okay? And then we have f triple prime of 0, and I'm going to write it like that, the third order derivative. And that is going to be, in this case, a negative 6 over 0 plus 1 to the 4th, so negative 6 times 1 over 3 factorial, 3 factorial being 6, leaving us here with a negative 1, and it alternates there as well. So let's see what our polynomial is, our Maclaurin or Taylor polynomial. It's the same thing because it's just about x equals 0. It's a special case of Taylor. So we have 1 plus, in this case, a negative 1 times x plus a 1, which we don't need to write, times x squared plus a negative 1 times x cubed, and so forth and so on. So what does this look like? Well, it's a negative 1 to the nth power multiplied by x to the nth. So that right there should help you understand and interpret what the Maclaurin series here is. It is going to be from n equals 0 to infinity. It is -1 to the nth power x to the nth. So I'm just going to tell you that if you are having trouble figuring out how I came up with this part at the end, think about what's going on with the numbers, with the powers, and I think you'll figure it out. Just might take some time. So if you have to, pause, rewind, whatever you got to do to figure it out, but it's not terribly difficult. Okay? So again, this is a little bit on the Maclaurin series, which is a special case of the Taylor series. And as always, I hope this video was helpful, and remember, like and subscribe.